All right, so we know what to do if we have numbers in exponential form multiplied by each other. X times 2 times x to the 4th. I take their exponents and I add them, and that equals x to the 6th. And we know what to do if we have numbers in exponential form that are divided by each other, like x to the 3rd divided by x, which is just x to the 1, is 3 minus 1, which is x squared. Well, what if I have a number in exponential form, like x to the 3rd, that's raised to an exponent, like a 4? Okay, so the first thing I have to do when I look at this is I have to say to myself, what does this even mean? What does x to the 3rd to the 4th even mean? Well, let me think about it. I know that when I raise something to the 4th power, I'm multiplying it by itself 4 times. Okay, so this is x to the 3rd multiplied by itself 4 times. So that's x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. Okay, so I know from 2 days ago that when I'm multiplying numbers in exponential form, I add their exponents. And look what I'm doing here. I'm multiplying their numbers in exponential form. So I'm going to add their exponents. So I have 3 plus 3 plus 3 plus 3 is 12. So I have x to the 12th. But remember, 3 plus 3 plus 3 plus 3, which is what we're doing there. There's a faster way to do that we learned in, I think, the 3rd grade. 3 plus 3 plus 3 plus 3 is the same as 3 times 4, right? So if we have x to the 3rd times x to the 4th, what does that equal? X to the 12th, which is the 3 times the 4. Let's do another one. If I have y to the 2nd power, and that is raised to the 6th power, what does that give me? Well, it's y squared times y squared times y squared times y squared, 1, 2, 3, 4, times y squared, 1 more, times y squared. Y squared times y squared times y squared times y squared. 1, 2, 3, 4, 5, 6. Well, that equals, I know that when I'm multiplying numbers in exponential form, I add their exponents. So here we have 2 plus 2 plus 2 plus 2 plus 2 plus 2. Well, that's the same thing as 2 times 6, right? Because I have 1, 2, 3, 4, 5, 6, which is 12. So I'm going to have y to the 12th power. Now, could I have done this more easily? Sure, I could have just said y to the 2nd power raised to the 6th power equals y to the 12th power. Now, okay, but why didn't I multiply them over here? Why isn't this x to the 8th? Shouldn't I multiply them over here? But remember, it's different. This is multiplying them by each other. This is being raised to a power, just like 2 times 3 is the same as 2 plus 2 plus 2, which is 6, 2 to the third power is the same as 2 times 2 times 2, which is 8. So they are not equal to each other. It's not the same thing. Here, we're multiplying the numbers. Here, we're raising this number to an exponent. When would we ever do that? Well, let me show you. Let me show you a practical application of this. Extremely common formula that I am sure you've seen before. Y, not Y. What am I doing? What in the world? This is Barlow. E equals MC squared. Well, that's all well and good, but what does any of these things mean? E is a variable for energy. M is a variable meaning mass. But C is not a variable at all. C is the speed of light in a vacuum, which is 3 times 10 to the 8th meters per second, okay? And that is squared. So if I want the value of that number, when we have a number in exponential note in scientific notation like this, we have to distribute the square to both of them. So 3 squared is 9 times 10 to the 8th squared. Now 10 to the 8th squared, I don't want to math that out, but I have a power raised to a power. So I know that I need to multiply them. So it ends up being 9 times 10 to the 16th. And the units are meters squared per second squared. But so there's a practical application of when we would actually use that in real life. And I've used that formula in my maybe not like my daily life, right? And making dinner and doing Einstein's relativity. But no, that's a formula that's really used really pretty often in math and in science and whatnot. So that's a pretty common one. So there's one where we can see that in action. Now let's see. Let me erase some of these. Let's see what happens. Let's just do a couple of these, and then we'll make some a little bit more complex. That one was a little bit more complex. Kind of jumped the gun because I was excited because, I mean, hello, physics. So let's do one that's just kind of straightforward without writing it all out. Let's say I have 4 to the 12th power raised to the 10th power. Now I could write 4 to the 12th times 4 to the 12th times 4 to the 12th times 10 times, right? Because it says 10 times. But I don't especially want to do that. That's not how I want to spend my life. So I can do this instead. I can say, okay, I know that 4 to the 12th power raised to the 10th power. I need to multiply those exponents together, and I end up with 4 to the 12 times 10th power, which is 4 to the 120th power, which is an enormous number. Huge, absolutely huge. We're not going to math that out. That would the calculator would not appreciate that. Let's do one more. Let's do one more. And then we're going to go on a little bit complex. So what if I have 5 to the 3rd power? And that is, do you notice we're always putting it in parentheses? That indicates that, hey, just this is raised to the 13th or to the 3rd power. If this whole thing is raised to the, I don't know, give me a number, 20th power. Why not, right? Why not? So 5 to the 3rd power, all of that is raised to the 20th power. So we need to make sure we have the parentheses, because remember, order of operations has to do parentheses first. We want to make sure that we're doing those parentheses first. Okay. So we have 5 to the 3rd power raised to the 20th power. that is going to be 5 to the something. 5 to the what? Okay, so let's look at this. We have 3 times 20 is 60. So 5 to the 60th power, which again is an extraordinarily large number. We're not gonna math that one out either. All right. So in here, we had 2 things. Can we do this with more than one thing in the parentheses? Sure, we can. Sure. As long as they're multiplied together and not added, we can just distribute that square straight through. If they're added, it's a little bit more complex, and we'll actually learn how to do that in algebra next year. If you have a burning desire for me to show you this year, let me know. I can accommodate that, but we won't be doing that in our class. Okay. Let's not use pink. I don't like pink. So let's use red. Let's say I have 3 times x squared times y to the 6th power, and all of that is raised to the, I don't know, 15th power. All right, we can do this. All right, so I just take them, they're multiplied, they're not added. So I can totally just distribute this 15 through this power of 15, and I don't have to, it's pretty straightforward. If they're added, this does not work. Okay, so 3, now remember there's an invisible 1, okay? 3 to the 15th power. So I multiply their exponents. 1 times 15 is 15. So 3 raised to the 15th power is 3 to the 15th power. More deep thoughts with Mrs. Barlow right there for you. All right, x to the 2nd power, so x squared raised to the 15th power. So it's going to be x to the something, but x to the what? Let's look at this. So I have a 2 in my exponent, and I have a 15. So I multiply the 2 times 15, which is 30. So x to the 30th power. Again, it's probably going to be a very large number. 3 to the 15th is huge. These are just big. They just get so big. All right, so y. So I have y to the 6th power times y to the 5th, or raised to the 15th power. It's not y to the 6th times y to the 15th. If it was y to the 6th times y to the 15th, I would add their exponents, but it's not. It's y to the 6th power raised to the 15th power. So I multiply the exponents. Make sure you watch your language. It's real easy to slip up, and you want to make sure you know what you're doing. Okay. So let's look at this. So 6 times 15. Well, I know that 2 times 15 is 30, okay, because I just did that. And I know that 6 is 2 times 3. So I'm going to say that 6 is 2 times 3, and then multiply that times 15. So I'm just going to take this 30 times 3. Now, what if you can't do that in your head like I just did, right? I don't care. Do this. Check this out. Oh, the calculator. There we go. 6 times 15 is indeed 90, like I just said. Okay, so are we done? We're done. We're done. So 3 to the 15th times x to the 30th times y to the 90th. And actually, when I have variables, I don't really need the multiplication sign in between. What if I have, here's another one. Let's do another one. I like these what ifs. Okay. What if I have 5 squared times 6 to the 4th? Because they're numbers, I do need a multiplication sign, but as soon as I get into variables, I don't. So x to the 7th, y to the 10th, and all of that is raised to the 5th power. I decided to not go too crazy with my numbers. All right, so do I combine these two first? Can I combine any of them? No, because the bases are all different. So I'm just going to leave all of those alone. The bases are different. I can't do anything with them. Wish I could. It would be lovely, but I can't. So 5 squared, 5 to the 2nd power, raised to the 5th power. So I have a 5. My base stays the same. 2 times 5 is 10. Times 6. Now what's happening with the exponent on the 6? I have a 4 and I have a 5. So 4 times, I'm not adding because it's not 6 to the 4th times 6 to the 5th. I'm multiplying because it's 6 to the 4th raised to the 5th power. 6 to the 4th raised to the 5th power is 4 times 5 and is 6 to the 20th power. That is a big number. Okay, x to the 7th raised to the 5th power. I have 7 times 5. That's x to the 35th power. And again, if you can't do that math in your head, I don't care. Grab a calculator. Y to the 10th power raised to the 5th power is y to the 10 times 5, and 10 times 5 is 50. So y to the 50th power, whatever that is going to be big. All right. I think that's probably pretty good. Let me know if you have any questions or any problems, and good luck. Bye.